Hello everyone, George here. In this video, we're going to extend the custom view we created last time and begin talking about ways of creating canvas objects that will perpetually redraw themselves to the screen. So if we're trying to get a little bit more complicated than drawing something simple like a background object to the screen, we need a way of containing these objects. And every time we want to redraw the view, we need to draw each one again and again and again. Drawing an object once is not going to cut it. We need to, of course, make sure we provide a backdrop, which is going to be our draw RGB, which in this case, I'm going to make that 0. The idea is that we're flushing the background. If you've ever dealt with OpenGL or DirectX or practically any computer graphics, you'll know that typically we flush our buffer at first, and then we redraw everything on top. What we're going to do in this video is extend and add some new functionality to our class that will make it behave a little bit more like, hesitate to say this, but a game engine. Not that that's what we're trying to do yet, because we're still very far away. We should be threading things. We should be potentially using a surface view instead. But for right now, we're just going to work with the basics. We're going to extend it as far as we can go, and in the future, we'll see what other things we can do. So right now, we've got a custom view, and we have onDraw. That's fine. We're drawing whatever's in there. But we want a way of storing the elements we're supposed to draw and then iterating through them. So what we're going to do is create a new class. So let's come over here to Java, right-click, New Java Class, and create a new class called Canvas Object. What is a Canvas Object going to do? Well, its sole purpose in our program is going to be to draw itself to the screen. The idea is that every canvas object we have is inherently going to contain the code within itself to draw itself. So as we add new functionality, as you add characters, as you add clouds or minions or ground or backdrop or stars, every single class we create knows how to draw itself. Now this is going to end up being an abstract class. We're never going to create a canvas object. Instead, we're going to continually inherit from the canvas object, which makes sure we have a particular method, in which case it's onDraw. So let's go ahead and hit OK. That's going to create for us our canvas object right here. Since this is an abstract class, we need to add the abstract methods future or child classes are going to have to implement. So let's go ahead and create a public. It's public because at the end of the day, what we're going to have within our onDraw method inside of our custom view is a for loop that's going to iterate through every single canvas object we want to draw to our screen. And when it does that, it's going to invoke this method that we're creating now. So let's do public abstract void, we're returning nothing, onDraw, and we're going to take in the canvas object called canvas. Let's Alt Enter to bring that into our import area over there. The idea is any canvas object we create inside of onDraw is going to be drawn to the screen. We have this function right now that's going to clear the screen first, and it doesn't have to be draw RGB. It could be drawing a bitmap or something else, but the idea is that's the first layer we lay down. And as we continue to draw objects, they get stacked on top of each other. This is very much like painting. We're drawing objects in the scene one by one, and if you draw them out of order, well, one's going to end up being on top of the other. How are we going to deal with our canvas objects? Well, we need to iterate through them, and the best thing to use with iteration, of course, is some form of a list, array, or whatever you want to call it. So we need to create one of them next. So let's do an array list, and the type is going to be canvas object. The idea is every canvas object, or every thing we draw to the screen, is going to be a canvas object, so why not just hold them all in a list? This can become far more complicated than what I'm showing you here, but let's not jump the gun yet. But the idea is you can make multiple lists like background elements, foreground elements, character elements, and draw them all in a series of orders that you find more important. A thing I failed, I believe, to mention in the last video is the fact that we're using the view class because the view class is GPU accelerated with its drawing commands. You might find other tutorials. In fact, we're probably going to do a tutorial in the future that deals with a surface view. The problem with surface views is the fact that they are not GPU accelerated. So there's going to be some slowdown. For simplicity, for acceleration, we're going to work with the view object. Array list canvas object, let's call this canvas objects, semicolon. Inside of our create method, let's go ahead and do canvas objects is equal to a new, let's see, array list, and that's it. Because this is, of course, Java 7, we don't need to include the type inside of the less than or greater than symbols. Now let's make a way for iterating over that. So let's make a for loop. So for int I is equal to canvas objects dot size. I is less than, oh my word, wow, I did that backwards. 0, I is equal to 0. Then let's do while I is less than canvas objects dot size, I plus plus. All right, so now we're going to do canvas objects, and of course dot, this is the array, so we got to do dot get. We're going to pass in that integer value and then do dot and onDraw. And of course, onDraw needs to take the canvas, which we have access to within our onDraw method. And that's it. Now that sounds pretty boring because we have no canvas objects with which we're drawing. So let's create a custom canvas object to show you the power of using abstract classes to enforce or impose upon us a series of methods that everyone will adhere to. So let's create a new class, right click, new Java class, and let's call it border. Our superclass is of course going to be canvas object, and it is not going to be abstract. Hit OK. Here we are. Hit enter a few times. It's going to complain about us not implementing that onDraw method. That's fine. Why don't we go Alt Insert and Implement and choose onDraw. And now we have our onDraw method. And we can put any code inside of here we want to. Since we have access to the canvas object, it's going to get drawn to the screen. So this is a border. And I chose this because it means we need to do a couple other things. Particularly, we need to know the size of our screen. If we're drawing a border, we need to know the X and Y extents of it. Otherwise, how will we know how far to draw? And we're also going to look at another function, which is inside of canvases, which is drawing lines. So let's go over to our custom view. It's incredibly common for people to think, in our constructor, that's where we're going to grab our size information. But the reality is, when the constructor gets called, we actually don't know how big the view is going to be. It's only later on, when the view gets positioned within the layout, that it has an exact size. So we actually need to wait a little bit, and we're going to implement a different method, or I should say override a different method to make this happen. So let's add some things to our scene to make this work. The first thing is going to be a public integer, and that's going to be screen width. Let's do another public int and screen height. The idea is we're storing the pixel height and width of our device with these methods. So now let's do screen width is going to be equal to, wait, didn't I just mention something about us not knowing the size yet inside of the constructor? In fact, if you were to continue this statement, you would end up with values, well, if we gave them default values, you'd end up with values of 0 because we don't know our size yet. We need to implement a different method or override a different method to get the proper size of our canvas at the time. So let's do Alt Insert and go to Override. So what we want to do is type on size changed, and this gets called whenever our size of the view changes. And this is a perfect chance for us to catalog what our new size is. So let's grab the screen width and the screen height. So screen width is going to be equal to W, and our screen height is going to be equal to H, which are the parameters passed in up here. And of course, it also includes the old width and old height if for some reason you need to factor that into any changes taking place. However, these are public integers. We actually need to be able to access this from all over our game objects. So it's going to be better if we make these static instead. Now, because they're static, they will have a value at first. But the idea is that our game objects are only really going to be doing anything during our onDraw loop. So all this initialization phase is going to occur first, and then within onDraw, we'll already have everything set up. So it's perfectly fine for our game objects to query this information in the future. Now, because they're public, that means other objects could potentially change the size, and that's a no-no. So let's make these private and create some getters so that everyone can have access to them. So let's do Alt Insert, and let's do a getter, and let's do our screen width and height. And the miraculousness of Android Studio means it automatically adds our static elements to that. Importantly though, we can now access from our border object these different sizes. And we're going to be doing something similar to this in the future when we deal with delta time, or the ability for our game or our canvas objects to query the amount of time that has passed between updates so we know how much they should move or animate whatever effects they happen to have. For our border object, it's actually pretty simple. There's not a lot that needs to happen here. When we're drawing with a canvas, when we're going to use different functionality that it has, we're actually going to want a paint object. So for the first thing we really need with this object is probably a constructor. So let's do that first. Alt Insert Constructor. So we're going to want to know how much of an offset we're actually going to want to have. To do that, let's create a protected int offset variable. And let's have that passed in when we create the object itself. And let's just do this.offset is equal to offset. There we are. We're going to use this value inside of onDraw to determine how much off the edges of our screen we should be drawing this information. So let's go ahead and start working with it. Let's do canvas. The function we're going to be doing is draw line. And if we hit Control P, we'll see the different parameters, and there's a start X, start Y, stop X, stop Y, and then this paint object. The paint object we haven't discussed, but the paint object is very important. It allows us to pass information to this drawing command and influence things like the color of the line, the fill, the stipple, and many other factors. And it really depends on the kind of drawing you're doing, what functionality happens to be implemented. So let's create a protected paint object. And inside of here, we got to include that in our project. And let's create a new paint object. So we'll do paint is equal to a new paint. And also, let's set up that paint object. So for a canvas object, I'm going to assume that paint is going to have a particular color. You can add these to your constructor parameters if you want to, so you can modify that from externally, or whatever you want to. But for right now, I'm just going to go with it. So paint.setColor. Let's do color. It's looking for an integer, and that's a hexadecimal value. We're going to use colors class and the static methods within that to create a color we want to work with. Now our background is black. Let's make our border, why not blue? And then paint.setColor. Let's do stroke width. Of course, is how wide in pixels that stroke is going to be. Let's make that 10 pixels wide, so we have plenty to go on. So of course, get stroke width is how wide this should be. So let's do set stroke width. And that's how wide this element should be. And let's just cap that to 10 pixels at the moment. And that's enough for us to set up our paint object so that every time we draw a line within our border, it is going to be blue and it is going to be 10 pixels wide. So let's go ahead and set up drawing our canvas line. Now we're going to want to draw 4 lines. Let's take a look at that now. So we're going to want to draw a border, and we're going to pass into that border some offset. And then from that offset, we're going to, of course, draw over, and then the offset, of course, will cut us off there. And then we're going to draw down based upon, once again, the offset and the offset. And we're going to do it again. So this offset value is going to be incorporated into each of these. So we're going to go from here, which is going to be basically the x coordinates are the offset, which I'll just designate with an O. And then, of course, the height, which is also the offset. And then we're going to go all the way over here. And then on this side, it's going to be the offset plus the width. And then it's still going to be the height value, or the offset value, actually. Then doing, of course, this draw down here, we are once again going to be at the 0, or offset, excuse me, plus width. And then, but our height value is now going to be the offset plus the height. And then coming, of course, over here, once again, it's going to now be just the offset for the x coordinate. And then for the y coordinate, it's still going to be the offset plus the height. And then we're going to draw back up here, and that's once again going to just be offset to offset. So let's make that happen. So that's in total 4 draw commands. So let's go ahead and just do the first one, and we'll copy and paste after that. So Control P, so we can see our parameter list. So start X. Let us go with, what convention do we want to use today? Well, I drew this clockwise, which is going to be DirectX style, starting at 0, 0, and moving on. So the first line is going to be a horizontal line, therefore X changes, but Y does not. So our Y start and our Y end are going to be the same value. So let's do offset for our X, and let's do offset for our Y, and then we're going to move in the X direction, so it's going to be the offset value plus some width. Well, what is the width? Well, we need to query now the information that we stored here, the screen width and the screen height, to figure that information out. Now, since we're kind of working with a view that shouldn't really change sizes because we've kind of constrained things in our layout to only be a particular size, we can store this value if we want to and work with it later on. It's really kind of up to us. But for right now, let's just make this a continually calculated value. Let's just do a float value. Int width is equal to, and then of course an int height is equal to something. Now the width is going to be equal to the offset times 2. Why? Because we have the offset from the left side and the offset from the right side. And we're going to be subtracting this from the total width of the object. So that's custom view dot get screen width. And we're going to do the same thing for the height, except of course in the height area, minus the offset times 2, because of course we need the offset on the top and the offset on the bottom. So here now we can start using this information. So remember, it is offset, offset over here, and then we move over, we move over the offset amount, but then we move over this width amount, and we stop short of that other offset amount. And that's why we did the whole times 2 thing, because there's 2 offsets, this one and this one over here. Coming back over here now, we can do offset plus the width. Now we need the final height, and because the height is constant, we can just do offset. Now we need the paint object, which we have created, our paint one up there, and we'll place that right there, put a semicolon on the end, and now we're going to copy this line 3 more times because there's 4 lines. So 1, 2, 3, there we are. Now the second one starts in the X area, not here, but instead the offset plus the width, right? Because we are over here now. So that's the offset plus all this distance we traveled over here. I should probably change the color, right? So it's the offset plus the distance to start here. But the height is still just that offset. But our X coordinate's going to stay the same. So it's still that offset all the way over here plus the width. But our Y value is now not just going to be offset, it's going to be offset plus the height of this. And remember, it is a positive this direction for Y and a positive this direction for X. You probably learned the inverse for Y in math classes. So just make sure you understand Y positive is down. Offset plus width. Now the X value stays the same, and over here we have the next offset plus width for the X value, so that's fine. So now we just need to start at the top, which is the offset, and we need to go to the offset plus the height. There we are. For the next line, we need to go from the offset in the offset plus width in the X direction. Let's give it a different color. Offset plus the width in the X direction at the start point, plus the offset plus the width in the height for that area. So let's do offset plus width and offset plus height. And we're going to be going back to the other side, which means we're actually only moving the X direction. So we just need the offset, and we need the offset plus the height, because we're still at the top, if that's what you want to call it, of the screen, even though it looks like it's at the bottom. And for the final bit, if you've noticed the pattern yet, we're always starting from this side. So we can actually copy and paste those values here now. We're always starting at the end of this point and moving on from there to the next area. And that's just going to be offset to offset, because we're going right back to the beginning. We're going from this place right here, different color, this place right here, back to the beginning, which is just offset by offset. This instead is offset in the X plus, offset in the X, and then the Y is offset plus that height value right there. Now that should be enough to draw our border onto the screen. So let's save that, come over here to our custom view. We need to, of course, create this object first and add it to our list, which we're iterating over, because right now the list is completely blank. So let's go ahead and do a canvas object.add, and let's add a new border, and we need to provide it with the offset. Let's make that 20 pixels as an offset. And if we go back to our border, how thick do we make it? So it's 10 thick, which means 5 on each side. So we're going to have 15 border off the side. Now remember, this is not yet dealing with different device ratio densities and how many pixels are on the screen. So you will have a different looking environment on the device you decide to test with. We'll be dealing with that later on as we get into further topics inside of Android. Let's go ahead and hit run. I'm gonna hit OK. Let's bring up side sync and bring up the phone screen. There it is right here. So we rotate automatically and we bring up the screen, and here we are, a black screen with a blue border. Now this probably doesn't sound amazingly interesting to you at this point, but think about what we've done. We've grabbed the screen width. We've made it accessible to other objects. We've created a custom abstract class that other objects will be inheriting from, and all of them need to implement onDraw. And when we create them, hopefully they'll be added in some way. We'll get to ways to adding these things later on, but they'll be added to our list. All of them get drawn to the screen one after the other, predictably and reliably. So we can make all manner of amazing things with this now. So in future videos, we're going to cover a lot of things. We're going to come back to this, but obviously we're going to talk about drawing in different ways using bitmaps and other things, and creating different cool objects for our field. But more importantly, in the next video, we're going to talk about time, because right now we have no idea about the passage of time from one update to the next. We're going to talk about how we can use system.getCurrentTime, storing that information to calculate the delta time between updates. And with that delta time, we know how much to update animations. And we'll be making some pretty cool effects. George out.